I guess in this video, we are going to compare Mistral with BioMistral large language models. We are going to feed PubMed articles in the RAG pipeline. So there will be two RAG pipelines. In first RAG pipeline, we are going to feed PubMed articles and going to use PubMed BERT base embedding with the BioMistral as a large language model. In the second pipeline, we are going to use all MiniLM L6 embedding with the Mistral large language model. Intention is to find out which model performs well and synthesis the retrieval chunks and give us better answer. So we'll search and download asthma and diabetes related articles from PubMed. We will ingest these PDFs to the RAG pipeline. We will prepare questions from the abstract of the downloaded articles using ChatGPT. So what we'll do is we'll basically take the abstract, we'll feed that or copy paste that in the ChatGPT, and we'll ask kind of a prompt like, okay, provide multiple questions from this particular abstract. Once we'll get the questions, we will ask these questions from the BioMistral and Mistral. So these questions should be same so that we can have a better understanding and we can properly evaluate the performance of these LLMs. And basically at the last, we will compare these answers. So the reason why we are using PubMed BERT embedding is it produces higher quality embedding than generalized model for the medical literature. And this is one of the popular model on medical literature. That's why we have used it and expecting a better result rather than using a normal generalized model. And we are using BioMistral 7B because of this reason. So it is utilizing Mistral as its foundation model and further pre-trained on PubMed Central. So as you know, in this video, we are going to compare foundation model, which is a Mistral model, and comparing it with the BioMistral because BioMistral has been further pre-trained on PubMed Central. So our expectation is again that BioMistral is going to outperform the normal foundation model Mistral. Okay, so now I'm on PubMed. Those who don't know about PubMed, they can search for it on ChatGPT. They'll get a decent answer of it. So PubMed is a free search engine accessing primarily the Bednight database. So it's a database about life science and biomedical topics. And there are over 30 million citations for biomedical literature from Medline, Life Science Journal, and online books. So person who are interested on these topics, they can search for users, topics, authors, journals, and access abstract or full text articles if available. So we are going to extract full text articles from PubMed. So we'll quickly go here and search for asthma. So I wrong spelled it and it is asking for did you mean asthma, and I'll quickly correct it. After that, you can see there is one filter called text availability and we are going to select free full text, and you can see a lot of articles here which are available here. You can choose any of them, but I'll go for something which is very much generic and I'll click on this. So once we click on any of the articles, we can go for free full text. And here you can see there is a PDF 1.2. Once I click on this, it'll open this PDF. So what I'll do is I'll save this PDF. Next, we'll search for diabetes. Again, you can see free full search is selected. I'll go for diagnosis and management of central diabetes, or I can click on this. Let's see if they have PDF format here. Can't see it here. I'll click on, I'll save it. Okay, so let's go through the code. These are the pip statements where we are installing Qdrant client, Langchain OpenAI, and Langchain community. These are the import statements, and you see in the left side we have asthma.pdf and diabetes.pdf. So we are passing these to PDF in unstructured file folder, and we are getting loaders. So we are going to utilize loaders for going through the documents, or you can say the documents object which we have got after fetching the textual data from this PDF. And we are going to basically see like how we can push and create embeddings and push the embeddings to the Qdrant server. But yeah, so next is LLM config, and we are using LM Studio. This is the LM Studio software which I'm running locally. And what this software is about is that you can download any large language model and basically run your local inference server using that large language model. So as you can see here, right now BioMistral 7B bit 4 has been already selected, and the moment I start the server, it basically provides me some APIs which I can use. So they have also provided the examples here how we can use the LLM APIs to utilize these large language models locally. So that's what I have done. As you can see here, there are three APIs which has been provided to me, and I can utilize these APIs in my code and make sure that whatever you download, it will be in GGF format, because GGF format is more CPU centric than the GPU centric. But definitely you guys can offload some layers of it into the GPU if you have GPU. So right now what I'm doing is I'm offloading 20 layers to GPU so that I mean, I don't want all the pressure to be on my CPU. I just wanted to distribute it. So yeah, so that's it. You guys can explore it. I'll go back to code. So what I've done is I've given the OpenAI API key not needed because I don't need it. I'm using, as I said, LM Studio Inference Server. So I'm providing that API here. Okay, so let's talk about Qdrant setup. We are creating a collection called DummyDB, and we are running the Qdrant vector database on local 633 port. So if we quickly go to their website, right, we'll get to know that the way to run Qdrant server is to have a Docker. I'm not going to talk about Docker because it is itself a big topic. So those who don't know about Docker, they can go to YouTube and basically search for it. So you'll get a very nice content on Docker. So right now I have Dockers installed on my system. You can see the image quadrant is here and it is running on 633 port. So that's how you can basically, have your Qdrant vector DB running on your local machine. They also have cloud solutions. So those who want to explore, they can go to that option. Now let's get back to code, and I'm creating a client object here, Qdrant client, passing to the URL, and then I'm also creating a object for sentence transformers embedding, and I'm passing right now all mini L6v2, which is wrong because right now what we are doing is in our first rack pipeline, we are not using all mini LM L6. We are going to use this in our second pipeline. In the first pipeline, we are using PubMed BERT embedding. Okay, so what I'll do is I'll quickly go and copy this here. Yeah, we are going to create embeddings from PubMed BERT based embeddings, and then we are also creating the Qdrant object here. Okay, fine. So next we are creating a prompt template where we are passing the context and question. We are making sure that it should not hallucinate. So don't try to make up an answer. Then we are passing this prompt template into prompt template object, and then here we are using loaders. So what we have done here is we have passed the two PDFs and we were getting loaders from unstructured file loader, and here in the loaders we are looping the loaders and we're getting the raw documents. We're passing these raw documents, but before that we are making sure that we have created recursive character text splitter, giving chunk size 800, chunk overlap 100, and then with the text splitter we are splitting these documents and we are creating chunks. So once we have the collections, we will pass collections embeddings Qdrant URL and collection name to Qdrant dot from document. So the moment this line gets executed, it will create embeddings from the chunks and then it will save those embedding vectors to the Qdrant server. So if we quickly go to the Qdrant server dashboard, we can see that these are the collections right now. We can't see DB, but once we execute our code, we can see the dummy DB here, and we can also see the chunks from the DB. So next we'll create retriever. So we are using retrieval QA, and we are creating this thing. We are passing large language model object. We are passing retriever, and then we are keeping the verbose equals to true so that we can see some logs. Once we are done with the retriever, what we will do is we'll basically pass the query here. So as we have talked about, right? So next step will be to create some queries from the abstract, which from the asthma and diabetes PDF. Okay, so we'll take the articles, we'll get the abstract of it, we'll copy paste it into the chat GPT and we'll try to get the question so that we can pass those questions here and get the. So this is the first asthma PDF. If we go down, we can see the abstract of this PDF article. We'll take it and we'll go to ChatGPT. We'll provide this here and ask the provide two questions from the below text, not more than 20 words. We are keeping the question small. What factors commonly trigger asthma exacerbations, and how does the guideline-based management address asthma exacerbations? So these are the two questions we are going to consider in our RAG application. So we'll copy this, we'll paste it here in the query. And what we'll do is we'll copy this whole thing, paste it one more time so that we can provide the other question here. We'll go back to ChatGPT and we'll paste it here. So these are the two questions for which we are expecting answer. So what we'll do is we'll quickly run this whole Jupyter notebook. So we can see that this particular cell is taking time to, because this is a line where the documents are getting extracted and getting chunks are getting created. And as I said, if we go to the quadrant server, if we run it, we should see the dummy DB. Yeah, we can see the dummy DB, and these are the page contents of the chunks, right? These are all the chunks. And then if we go to the info part of this collection, we can see that these are the vectors, 142 vectors, which has been created. Now it is executing the second one. And again, if we go to LM Studio, we can see that it has also started giving the answer. So very soon we'll also have the answer. So yeah, we have the answer for the second question also. Okay, so this is a new Jupyter notebook, which I have copied from the previous one. And this will be our next RAG pipeline. So in this RAG pipeline, there are only few things which we have to change. Otherwise, the whole code will be same. So these are the PDFs. It will be same. We are going to make the collection name different so that we can have a new collection. We have changed the embedding. Previously, we were using the PubMed BERT embedding. Now we are using all MiniLM L6 V2. And the third thing is large language model. So we'll change it here. So as you can see here, in this case, we have Mistral 7B. Okay. So we have made the changes and we are going to run this whole pipeline. But before that, just making sure that everything is in place, we'll quickly run the whole notebook. So now that both the questions and answers has been executed and we have the answers, let's compare them with the BioMistral RAG. So guys, these are the answers from both the large language models. In the left side, we have BioMistral. In the right side, we have Mistral. And be the judge. Comment down that which one you like better. This is the second question, and these are the answers. This is the third question, and these are the answers. And this is the last question, and these are the answers. Personally, if you ask me, I like Mistral. My expectation was that BioMistral with PubMed BERT based embedding would have given me much better answer, but I did not felt that. And yeah, so that was a surprising factor for me. Hope you have learned something in this video. And that's all for this video, guys. Thank you. Thanks a lot. Bye. Have a nice day.